This video will be over section 1.4 in college algebra in context, equations, objectives. We will write equations of lines using the slope-intercept form, the point-slope form. Write equations of horizontal and vertical lines. Write equations of lines parallel or perpendicular to given lines. Find the average rate of change over an interval for nonlinear functions. Find the difference quotient from point x f of x to point x plus h f of x plus h. Find the average rate of change for approximately linear slope-intercept form of an equation. The slope-intercept form of an equation is of a line with slope m and x-intercept b. You realize that's at the point 0b, is y equals mx plus b. In applied context, m is the rate of change and b is the initial value. A plumber charges $65 for a service call plus $30 per hour for each hour spent on the repair. Assuming his service call charges can be modeled by a linear function for the number of hours spent on the repair, write an equation for this function. Well, our equation, we're going to put it in slope-intercept form. Y equals the cost per hour is $30. So 30 times x is the number of hours we're working, plus the initial $65 service charge. The rate of change, the initial amount. So this becomes my equation. Now the point-slope form of a line, equation with a line, again we have slope m, and it passes through this point. We don't always know the y-intercept. So we take y minus the y value of the point equals m times x minus the x value of the point. Let's see how that works. The equation line that passes through this point. So it's my x1 and my y1 and slope 1/3. So y minus -4, the y1, equals the slope 1/3 times x minus x1, which will be -3. So it'll be y plus 4 equals 1/3 times x. 1/3 times -3 is -1. Now we'll want to get the 4 to the other side by subtracting 4 from each side. Y equals 1/3 x minus 5. And this becomes our equation. Here they give us just 2 points, and we need to find the equation of the line. Well, we know how to find the slope. So remember, it's rise over run, so change in y, 7 minus 3, over the change in x, 4 minus -2. So we'll have 4 minus -2, that's like plus 2, 6. And of course we reduce to 2/3. Now we can use either of these values. So y minus 7 equals 2/3 times x minus 4. Do make sure you use the points from the same ordered pair. So y minus 4 equals 2/3 x minus 8/3. And we'll need to add 7 to both sides. And remember, the 7 is 21/3. So y equals 2/3 x, adding 21/3 to -8/3 will be plus 13/3. And it's okay to leave an improper fraction as long as it's reduced. You do not have to change to a mixed number. The number of people in millions in the United States prisons and the jail grew at a constant rate from 2001 to 2009, with 1.345 million people incarcerated in 2001 and 1.617 incarcerated in 2002. What is the rate of growth of the people in prison? The rate of growth, that basically is m, or the slope of the line. So the years are the x's and the million of people are the y's. So the slope is the y2 minus y1 over x2 minus x1. On the numerator, we'll get 2.72, and the denominator will get 8. When we divide that, it comes out to 0.034. So this would be, the rate of growth would be 0.034. Using the same information, we want to write a linear equation that models the number n of prisoners as a function of the year x. Let's use point slope form. So n minus, let's use the 2001, 1.345. So n minus 1.345 equals the slope 0.034 times x minus the 2001. So n minus 1.345 equals 0.034x minus 68.034. And now move the 1.345. So n equals 0.034x minus 66.689. Want to know we have that the Pew Center of the States projects 1.5 million people incarcerated in 2001. Does our model agree with that prediction? Well, let's use the equation we just wrote. N equals 0.034 times our x becomes 2011 minus 66.689. Doing the calculations, n equals 68.374 minus 66.689, or n equals 1.685, and of course this is million, and that would round to 1.7. Agree with the projection? Yes, it does. The equation of a vertical line is the form x equals a, where a is a constant and a is the x-coordinate at any point on the line. So when we have a vertical line, if this is our axis, this would be a vertical line, and x would equal that value a any place on that line. A horizontal line, those were the axes, would be here, and the x values keep changing, but the y value is constant, y equals b, anywhere on that line. We also can have parallel lines. Parallel lines. Two distinct non-vertical parallel lines are parallel if and only if they have the same slope. They have to have the very same slope. That makes them parallel because slope does determine how they slant. It turns out if we have perpendicular lines, and you remember perpendicular lines cross at a right angle, neither of which is vertical, so this wouldn't work. Let's do that. We can also know about the slope of a perpendicular line. So neither of which is vertical. So if we had that perpendicular line and that perpendicular line, they cross at a right angle. This slope, if and only if their slopes have a product of -1. Thus, the slopes of perpendicular lines, neither of which are vertical, are negative reciprocals. So a negative reciprocal, if 3 was our number, the negative reciprocal could be -1/3. Or if we had a slope of 4/3, the negative reciprocal would be -3/4. That's what we mean by negative reciprocal.